Hello again, let's look at this next example. Consider f of x equals x to the fifth minus 3x squared. Let's just say I want to find dy as a function of x in general. Let's say I don't want a particular numeric. Let's say I don't want to fix x, I don't want to tie x down to any particular numerical value. Let's just say I want to find dy. Okay. Well, let's see here. Note that dy is the differential of f. So, but anyway, that's neither here nor there as far as finding dy. So dy equals f prime of x dx. Now f prime of x is just, of course, by the power rule, 5x to the fourth, and by the sum difference rule, minus, and then do the power rule again, 6x, and then parentheses that dx, and that's it. That's dy. Now, if we wanted the tangent line approximation, let me type that out here. If we wanted the tangent line approximation, we would get, and well, what would we get? We would get, let me bring that back up here. I don't want that far down. We would get, well, let's see. F of, let's just say, we would get f. Now the real McCoy is f of x plus delta x. But now we're not going to find the real McCoy. We're going to get we want the tangent line approximation. Actually, no, never mind. Let's just get dy. So if we wanted the tangent line approximation, yeah, sure. That would be f of x plus delta x. And then that would approximately equal, well, that would approximately equal alpha. Delta x, guys, remember, delta x is just dx, okay? Anytime you see delta x in this context, it's dx. Now, there may be other situations where delta x and dx are not equal, but in the context of the tangent line approximation, they are. They're the same, identical. So f of x plus delta x, that's approximately equal to f of my original x, and then plus f prime of my original x times delta x. Or you could call it really, and I'll just say delta. Dx and delta x are the same guy, but I'll use delta x. You could just as well call this delta x here dx. But anyway, there's that. And I guess it'd be good mannered. Let me use dx. Either way, I think it's more common to put dx here just out of tradition. Dx and delta x are the same thing though. But anyway, that would be, now what would this be in terms of I've got a particular function though. I do know what my function is, and I do know what f prime is as well. So f of x is going to be, well, so I've got x to the fifth. My f of x is just x to the fifth minus 3x squared. Now plus, I'm going to need a parenthesis. Now f prime of x is, we determine it's this guy right here, and then dx. And that's awful, that's not pretty to look at. Let me see if I can font that down. That's, there we go. I hate it when it wraps lines. So there's that. Yeah, maybe to behave itself. So we just get this guy right here. And I could go ahead and distribute this. I could get x to the fifth minus 3x squared and drop the parentheses and put plus 5x to the fourth dx and then minus 6x dx, but I won't bother, okay? Here it is. So now the tangent line approximation would just be, well, this is correct. It's just this guy right here. The tangent line, if we would get this guy right here. Now, what I said a minute ago was correct. That you're like, well, Jason, why'd you delete your equals and all that? Let me put because, hot dog. And I'm gonna put because f prime of, excuse me, nah, I'm screwing up like crazy. F of x plus delta x. I can't even type anymore. And then I kind of wish I wouldn't have deleted my stuff so soon. I wish I'd have copied it first, but anyway. And then equals, because is approximately equal to this. Remember from That's the whole point. F of P is approximately equal to F of C plus F prime C times our dx. Okay. Now remember, if you replace x with c, you don't say dc. You still say dx. Okay. But anyway, and that's spot on equal to. And of course that equals this guy right here. But anyway, so there's that. So f of x plus delta x is approximately equal to this guy right here. Okay. So there's that.